This is number 9 from the in-class worksheet from Monday, March 5th. We are dissolving copper wire in silver nitrate to form solid silver and copper 2 nitrate. So we're going to write the balanced chemical reaction. We start with metallic copper and we are dissolving it in silver 1 nitrate. So silver 1 has a +1 charge, nitrate has a -1 charge, so we just need 1 silver and 1 nitrate. The results will be copper nitrate, and since it's copper 2 nitrate, we need to have 2 nitrates to balance out each of the copper 2 plus ions. And then we will also make metallic silver. We need to balance out the nitrate. There's 1 nitrate in the reactants, so we need to have 2 nitrates in the reactants, 2 nitrates in the products. Since there's 2 silvers in the reactants, we need to have 2 silvers in the product. Now we can write half reactions. Our copper metal goes to copper 2 plus ions, which means there's a 2 plus charge in the products. We need to balance the 2 plus by adding 2 electrons. Since electrons are product, this will be our oxidation half reaction. Our silver ions, and there are 2 of them, are a +1 charge, and they are converted into silver metal. Each of the ions has a +1 charge, and there's 2 of them, so that means that the reactant side has a 2 plus charge. The 2 electrons that were produced in the oxidation of copper become a reactant in the reduction of the silver ions. So this is our reduction half reaction. Now that we have our balanced chemical reaction and our 2 half reactions, the oxidation of copper and the reduction of silver ions, we can do the stoichiometry portion. We're starting with grams of copper. There's 0.55 grams of copper. And we want to end up with liters of silver nitrate solution. So our strategy is going to be to go from grams of copper to moles of copper to moles of silver nitrate solution, and finally end up in liters of our silver nitrate solution. So if we start with grams of copper, we want to convert this to moles of copper. We're going to use the molar mass or atomic mass of copper from the periodic table, which is 63.55 grams per mole. So we will put 1 mole of copper on the top is equal to 63.55 grams of copper. So our grams of copper will cancel out. We're in moles of copper, so we want to convert that into moles of silver nitrate. If we look at our balanced chemical equation, for every 1 mole of copper, we need 2 moles of silver nitrate. So we will put the 2 moles of silver nitrate on top, and 1 mole of copper on the bottom. Then our copper will cancel out, and we're in moles of silver nitrate. We're going to use the molarity as a conversion factor, and this 1.25 molar can be rewritten as 1.25 moles per liter. When we're using this as a conversion factor, we want the moles to cancel out, so we will put 1 liter on top, and on the bottom we will put 1.25 moles, and that's moles of silver nitrate. Our moles of silver nitrate cancel, and we can do the math. 0.55 grams divided by 63.55 times 2 divided by 1.25, which will end up being 0.014 liters of our silver nitrate solution.